Hi, my name is Yuri. I did a lot of fun projects in my time, and I'll tell you about some of them today, if I figure out the button click thing. So as you can tell from your screen, Rust is really good for the cars. We want to adopt even more of it. And let's begin about me very briefly so I don't brag too much. So I focus on maps. That's almost like me right there, drawing a map. My career began here in Seattle as an intern at Microsoft. And I focus mostly on open source software. Co-founded MapLibre, which is the map rendering stack most likely you have on your phone. And Microsoft Bing Maps uses it, and a lot of other projects. I lead maps, especially data efforts at Rivian. And I also like Rust a lot. Even got a temporary tattoo here. And I'm going to talk about that, because recently Rivian spun off a joint venture with Volkswagen. We now call it Rivian and Volkswagen Group Technology. And we do lots of fun Rust adoption. So about Rivian. We do electric vehicles. You see quite a few of them driving around here in Seattle. SUVs, trucks, focusing on adventure. You know, what kind of truck or SUV? How can you have an adventure without having a tent on your rooftop? We also help deliver mail, packages, and sell ice cream. That's probably the most important thing. Now, let's talk about the Rust adoption. Rust fits pretty much everywhere, as you can tell from the image, with various degrees of success. But more focused on Rivian adopting Rust. You see, a modern car, is hundreds of computers. Most of them are in the vehicle. They also talk to your phone, cloud services, web. All of that, to various degrees, could use Rust. Some use it better, some use it not so well, and we're going to go into details there. The first and foremost, the easiest path of adoption Rust is to do some tooling. You know, you show clap derive to developers, and they're like, oh my God, I can parse CLI arguments like very easily. They love it. They get started with it. Then they learn all the other Rust tooling, and they're very happy. Cloud services, also very good. Some competition from garbage collected languages, but we're not going to go too far into that. On the vehicle, it's almost as easy, especially if it's for the computers that have operating systems on them. You start a new process, works beautifully. Mobile phones, also, I mean, Android and iOS have their own programming language, but you can still have Rust there quite easily. The moment you go into embedded devices, like systems and chips, no operating system, things get slightly hairier, still totally worth it, especially if you do the whole thing. And WebAssembly. Enough said there. WebAssembly is really great if you want to share code, but size constraint and other things matter. So, now, let's go into common gotchas. What things I've noticed about Rust code when adopted, especially by C++ developers. Oh my God, you can have curlies in the same spot for all the projects? Seriously? Developers are shocked, but there is a one standard formatting style for everyone. They love it eventually, once they get used to it. It takes a while. That's probably even longer than the 2 months that Mark was talking about of general Rust adoption. Well, not really. C++ loves to see their warnings. They're totally OK for the full wall of GCC, LLVM warnings, and OK, it's fine, it's OK, it's a warning, it's not a big deal. Right, not so much in Rust. You're like, it's a warning. No, CI will say no. So enforcing with CI, Clippy warnings. I love Clippy, especially in pedantic mode. I actually contributed a few Clippies myself, just to annoy people. No, not to make the code better. locking versions. Do not do what you see on your screen. Bad pattern right there. I've seen it time and time again because C developers specifically, they love to control their build environment. I can't really blame them this way. But what they do is they lock the version of the dependency without realizing that the sub-dependencies are not locked this way. So you have to educate. Lastly, we're brave C developers. Unsafe ain't scares us. No, don't do unsafe, especially if you just started Rust. No, that's the last keyword you should be using. Tools and cloud services, let's go into details on all the ones I've mentioned. So tools and cloud services, as I said, are the easiest ones to get started. Great for education. You educate developers how to start, how to use them, works beautifully. The only hard part is competing with garbage collected languages. You have to show why you're doing this tiny 5-line tool in Rust rather than Python. Obviously, it's easy to write code in Python. It's hard to maintain code in Python, and that's where Rust really wins. Once you go into software, I love AI-generated image, just by the way, so do forgive me for those. When you have an operating system running in the car on a computer, one of the computers, many computers, it's very easy to build a standalone process there because there's a lot of standalone separated processes, and the only things you need to do for them is to provide some common wrappers for messaging, for example, so they can communicate with other processes. But that's it. It runs out of the box, basically. Good examples of good things that received adoption quite readily is over-the-air updates. You know, modern computers, cars, they all want to be self-updated like every few weeks, and that's the new normal. And so that works quite well. One other thing for this, and I'll mention this later on as well, is in the car, there is safety critical and just don't break my vehicle critical. And if your brakes stop working, it's really bad. But if your self-updater breaks the vehicle, it's really bad, but not as bad as the first one. So there's a certification on all that stuff. So Rust is much easier to adopt to the things that run when the car is parked than when things are running, and safety critical again. So hard part in adoption here, giant monorepos, CMake integration, Bazel integration. Bazel works in workspaces, doesn't work well with modules, the new modules, whatever. There's a lot of these challenges that have to be worked through. And they're constantly being solved, but these are the challenges. Integration with current C++. Again, if you want to reuse a lot of C++ libraries, and you have to, then you have to have a professional Rust developer wrapping them for the other novice Rust developers to just use and not use the unsafe everywhere. The other types of devices are system on chips. Those are tiny little chips that are everywhere in the vehicle, and they do not have an operating system. Sometimes they have a real-time operating system, which is they're much easier to adapt to because they all mostly C, not C++. BindGen works beautifully. On the other hand, unless you do a full rewrite in Rust, the benefits are less. And it's really hard to rewrite large code in Rust. Well, AI helps a lot nowadays. Also, as I mentioned, safety critical versus not safety critical. Like, if you cannot open the car door, really bad, but at least you can much more rapidly innovate in that space than something like brakes. There's all the certification, MISR certification that developers ask for, managers ask for, ASIL certification. There's some movement in that space, so that's a good thing, but these are the things that people expect to ask. Also in embedded stuff, mental model misfit. Embedded developers love global state, global variables. they do not like to pass variables by parameters to functions. So you have to educate and manage the expectations and just see how well you can adopt Rust model of calling functions compared to what they're used to. Bootloader is actually a very good example of something that's relatively easy to adopt. Rewriting bootloader gets, like, it's standalone separate from the regular software. It usually only runs when the car is parked, when the car starts up. So there's a lot of opportunities there. Plus, there's a huge opportunity to really standardize the whole industry one way or the other on a common bootloader paradigm so that the car can do self-updating and other things and get the chips started. The other concern with embedded, and I'll spend a little bit of embedded because it's a big part of modern vehicles, is various chipsets. So SMD, for example, has an amazing stack, amazing support, and a lot of code just works out of the box for getting started really rapidly. Embassy's own HUL and others are just truly amazing. Just kudos to Embassy folks. On the other hand, Infineon and high-tech compilers, those are great chips. They're very commonly used in automotive because they're like very safety-focused, but they don't have as much of a Rust support. And they are really looking for a community to really help them move into the same space, into the same level of quality as SMD and Cortex, other stuff. Another opportunity here is, well, you see, if an embedded chip is shrunk from, I don't know, 128 kilobytes to 64 kilobytes, that's like tons of money saving because you have a lot of these chips in the car and you have a lot of these cars. So instant millions and millions of dollars of savings. So the question is, can we get rid of the RTOS and switch to Embassy and do like async await style programming? Again, this is something that's being researched. Has not been adopted yet, but a huge opportunity there. Web and mobile, as I said, mobile is easy if you can go through the Android, Java, Kotlin code versus Swift in iOS. Some challenge there. With WebAssembly, let's just make that WebAssembly slightly smaller somehow, and otherwise, all good. Sharing code, WebAssembly is absolutely awesome for sharing code between projects. MapLibre, the project I spend a lot of my free time on, a lot of opportunities there to share code between the web version and C++ version, and then somehow migrate it all to Rust. There's other aspects completely separate from technology. Not exactly party. Adoption is really hard. I love my COBOL, go away. How many of you heard that one? Perl? No, never mind. Innovation risks. Engineers love it. Upper management loves it. The management in the middle, project manager, well, we're going to ship it with some delays. Could you tell us how long it will take? Or has anyone else done this here before? I mean, it's kind of risky. We don't want to do this. Or it's just too much of a risk. So there's a lot of work to adopt socially rather than technologically. Safety certification. That's another big thing. Here, we are officially certified by ASLD, and we have MISRA compliance, and what's the story in Rust? And you go, well, most MISRA compliance stuff is not even applicable to Rust, but, and then the story starts there. Lastly, a lot of common libraries. There's a lot of work to do FFI, and that means hiring Rust developers so they do the professional FFI work, because you don't want novice developers starting on FFI. Bad thing. So one other thing is what I call Rust in the box. You have a company that has no infrastructure for Rust. They don't have crates.io. They don't have CI. They don't have compilers. They don't have anything. Now, they need to get started somehow. So what I found quite nicely is Koner, for example. I'm probably mispronouncing the name. It's like a crates.io on steroids to run inside a company. Amazing project. So you can upload crates, private crates to it. It does the same like ducks run and whatever, and shows the documentation for the private crates. And it's really good. Unfortunately, it doesn't support custom compilers because guess what? In a big organization, they want to control which compiler they use. So it needs to have that. CI/CD, you need to set it up. You need to explain how to use it. Clippy, formatting, all that stuff. You need basic reduction of barrier of entry. The lower, the better. Kind of obvious. And obviously, Clippy and format and all that, you have to explain how to use those. So results so far, where are we? Lots of OTA stuff. Very successful there. Messaging pipelines also works quite nicely because there's a lot of different support for different type of messaging and different application, different layers. Tools. Devs love their tools, and to write them in Rust as an experiment absolutely works. Some embedded evaluation projects works well. The most important thing is CEO commanded it. CEO says, yes, it is our main initiative. We must adopt it wherever it fits. It's in our strategic advantage. What doesn't work too well? We love to have fun and discuss Rust. Let's meet every week and talk Rust cool stuff. We had awesome time. 5 people usually on average showed up. Not very good for adoption. Great to have fun. What does work? Tiger teams. Figure out some deliverables, something concrete. I need to do this, or the team needs to do that. Get a few developers. Junior developers actually worked out better than senior developers because they're more excited to try new things rather than buried under all sorts of responsibilities that they have. So that worked quite nicely. And once this Tiger team works, this tiger hasn't grown up yet. Once the Tiger teams work through the projects, they gain the knowledge, they review each other's code, and then they can seed other teams with their knowledge. It's like teach the teachers. You establish good practices, you put them in different teams, they know of each other, different teams start talking to each other. This whole siloing, which is very common in the especially automotive industry, gets broken down the moment you have a language focus rather than transmission versus engine type of focus. Our CEO wrote this big thing about we have to adopt Rust because it really shifts the quality in our favor. I'm not going to read it, but it's just an amazing thing that promotes Rust usage across the board. So, in summary, build small teams. Teams that focus on Rust, learning from each other, reviewing each other's code, teaching others. Make sure there's an expert to review whatever they're doing, because otherwise they're very proud of what they've achieved using AI, and their limited knowledge of other languages together combined with Rust, and then the result are oh, this is great, and there's only 3 unsafes in the code. That's perfect. And you're no, you should just think about the whole thing differently, and then you teach them. So there has to be an expert Rust teaching these things, and then it works. The lower the barrier of entry, the better. Figure out small scope projects. Assign people to do them. Hire Rust experts. You can grow your own local internal Rust experts, but usually it's much easier and quicker to have Rust experts like one of you or many of you joining the company, and then sprinkle them around to seed the whole growth. Now let's switch to the community aspects, because there's other things that we as a community can do to help this adoption. When I start using a crate from Crates.io, I would love to be certain of its future. And if there's only a single owner of that, great. Then, well, they do go on vacation on occasion, I hope, otherwise they get burned out. They do get sidetracked with other projects. So let's encourage multi-project ownership. Maybe Crates.io should rank higher the projects that have multiple owners versus one. Business adoption cases. Just as I said, Rust in the box really helps. If you have a path, like a big document, even that will help. This is how you start private Rust ecosystem inside a company. Work with system on chips companies. They have all this hardware, but really poor, some of them, really poor Rust support. So make them more or less on the same level so they can all easily work with Embassy and the likes, or there's some Rust RTOSes, to get started quicker. Because otherwise, this barrier of entry, you don't want people spending months and months figuring out how to do Rust and how to onboard the specific chip and do other learning. It's like the less learning you can do, the better. And lastly, let's encourage private companies to set up funds, FOSS funds, where individual managers can say, look, this technology is critical for our business success. We do not want it to go under. And let them pick a portion of that fund and spend it on supporting FOSS projects without going through a giant list of all the checks that they have to go through to support an individual developer or a small group for something that's critical. It's not in anyone's interest if a critical component, like you've seen in XKCD, just kind of like a little stick there, just kind of collapsing, and no one was supporting it because everyone assumed someone else was supporting it. So that's something that is critical for business to support open source. Which I thank you, and I'm open for questions. Oh, and we are hiring Rust developers. So thank you so much. If there's no questions, I can let you go for earlier.
I have one quickly. First of all, thanks for the talk. I'm curious, you mentioned MISRA compliance a few times throughout your talk. Have you heard of the Ferrocene toolchain, and is that seen in the automotive industry as an equivalent, or?
Oof. So Ferrocene has done ASIL-D certification of one of their compiler, one of the versions, if I remember correctly. I don't believe they did MISRA certification, and MISRA group itself tried to do a run through their C requirements and see which ones fit and don't fit the Rust. I might be mistaken this one. So, but there's a lot. The answer to that question is not clear. That I do not have a clear answer to give to others at Rivian or Rivian VW technology. There's no clear answer for me to give them yet, unfortunately. So hopefully there will be. But basically it is something that many managers, project managers ask for because they need some certainty, and certification kind of offers that certainty, especially in safety critical aspects.
Thank you.
Hey, yeah, so I also had a question about the safety stuff. I wondered if you could just talk more about what makes it difficult for Rust projects to get the safety certification? Because before you said that it was harder to use Rust in safety critical stuff, my default assumption would have been like, oh, that's the natural first place for Rust.
There used to be this acronym, FUD, fear, uncertainty, and doubt. In a way, it is partially that. We don't know what we do not know. So when you adopt a new technology, yes, you claim it's safer. Has it been certified as being safer? Here we have C, which we know, like we have this giant list to go through to make it MISRA compliant. Therefore, if we go through that list, in theory, we're not responsible. Well, I mean, everyone obviously is responsible. And there's always bigger importance in terms of bugs per mile type of thing than, or crashes per mile, than compliance. But compliance makes it much lower, like much smaller concern because we went through the checklist. We actually got most of the common gotchas. Rust is just bigger unknown in that space.
Thank you.
Yeah.
Hi. How do you handle the case where you have a group of, let's say, distinguished general people that have been around for a long time, and they're like, I want to use my globals, and Rust just did it wrong to not let me do that. Like, the number of times I've had to hear people tell me that Rust did something wrong just makes me want to rage inside.
Well, you have to do proofs of concept, show how doing certain things in a Rust way benefits them overall. And I mean, mostly this is embedded cases. So that's why I was saying that ideally the entire chip software should be written in Rust if possible. I believe the guy from Volvo, I believe, he was talking about this a lot. And he said that eventually they rewrote the entire system on chips firmware in Rust and got much bigger mileage out of it. So, but fundamentally, there's a lot of proving and discussion and explanation. There's no magic bullet. If you have senior developers who are set in their ways, you just have to work with them somehow to show that overall benefits outweigh the style of their coding before that, especially if you can prove that the overall firmware is smaller, if possible, faster, less buggy, more stable, which is a very tricky thing to do. But there's no magical answer. It's a much more of a social issue than a technology issue.
Thank you.
You can just make the CEO request it, which sometimes works, but sometimes.
So that was actually going to be my question, because you talk about how life is a lot easier when your CEO mandates this technology. So do you have much insight, or can you talk much about what led to your CEO adopting that position? There much, bottoms up, grounds up kind of grassroots effort before then?
Yes, it all started as a meetup, surprisingly. So at that meetup, when I joined Rivian, back then it was just a single company, Rivian, I started attending it, then I ran it. At one point we had actually hit it at 100 people attending it because we were all very interested in it. Lots and lots of grassroots interest. Slowly it subsided because there were no projects. Later on, some managers with experience with Rust said, well, let's try it in our team. Like director level said, okay, let's try it in our silo and see how it works. Let's educate some people. And when that worked out, and then when there was enough noise, and when stability of the system has been shown to be a significant resource, not constraint, but requirement, it was realized that let's reduce the resources required to make our software very stable and crash-free. And then Rust naturally came to mind because by that time we've been nagging everyone long enough that they were like, yes, it seems like that's the solution that everyone in the industry is talking about. Now let's do it. What is it needed to actually adopt it? And then you say, well, we have 90% of the code already written in C++. Can we just keep it that way? And then you say, no, well, let's start at least the newer projects. Let's try to slowly adopt it. Let's see which ones you can play with and to demonstrate how it works in different silos. And so it's a lot of, as I said, social work rather than technology work to convince people to get started. But if you're persistent, if you constantly nag Rust, they're like, okay, fine, do whatever. And then it works. kind of.
Hi, everyone. I think we can take, are you okay for 2 more questions?
Sure. If there's...
Feel free to come up to the mic, ask your question. 2 more questions.
Just a little curious about how the development path at Rivian is going. Is there still a lot of development work, or is it all just little iterative bits?
Tons of development work. I mean, we're constantly innovating. We're a new company, and now that we created this joint venture with Volkswagen, there's a lot of opportunities, a lot of innovation happening. So we're very excited about doing all this great work going forward. So, and especially when you adopt new technology that opens the doors to so much more innovation. Like, who would say no to that?
Cool. You just see so many of them driving around now that you'll wonder how much is left to do.
Quite a lot. You'll be surprised.
I think you made a really interesting point about companies. Rivian, I'm sure a lot of other companies are in the same boat where the engineers want to use Rust, and you have a CTO who really likes the idea of using Rust and sees these high-level benefits. And it's the middle management that is holding back. And the examples you brought up is it sounds like the middle management is identifying some very real risks. You know, can we deliver? Is this certifiable? So on one hand, I want to ask the question of how do you talk middle management into using Rust? On the other hand, it sounds like they're just the ones who hold all of the risk, and they're bringing up a lot of good counterpoints.
Exactly. That's exactly the case. Although we want to, have the cake eat it too. We want to switch to a very modern system. We want to have no bugs, and we want to ship it yesterday. No, you cannot do that. You have to explain that in some cases, the slower you start, the faster you go. As in, let's spend an extra week or 2 or even a couple of months learning the technology, adopting the new technology, so we can go so much faster later on. And we have a lot of proof from other companies, especially, and from the internal knowledge, that we can go much faster once we train and identify the paths and made the adjustments to the toolings. Because very often, the barrier of entry is the problem, not the middle management. It's more like, okay, I want to start on this little project, but for that I need this messaging pipeline, and I need this ability to generate, like there's all this Python code to generate all the other code, and it doesn't generate Rust, it generates C. So you need all these toolings to be adopted first. So, and then there's like a, by the time you're done figuring out the dependencies, you're like, okay, we have to ship tomorrow. That's problem. But once you're convinced that this is the path, and sometimes you need to go slower at first, then it kind of falls into place. And people start adjusting to this and get excited to move forward with this.
Thank you.
All right, please give Yuri a massive hand.
Thank you.